Guys, it's Mrs. Millison. Okay, I'm going to go through how we're going to assess normality for a distribution. Okay, now 9 times out of 10, you're going to be told a distribution is approximately normal and you're going to be given the mean and the standard deviation. But you're going to see a couple questions on the AP test to determine whether a distribution is normal. Now, there are lots of ways. There's 6 different ways. I highly doubt you're going to have to do all 6 at one time, but I got to show you all 6 because you never know what you're going to get to be able to work with. Okay. First things first, all normal distributions are approximate or are symmetrical and unimodal. So that should be your first line of defense. Look at the shape. Okay, is the shape symmetrical and unimodal? I would say that's roughly symmetrical. And definitely unimodal. Okay, so without a doubt, the shape is good. If I was looking at a distribution that was very grossly skewed left or right, I would say no, there's no way it can be a normal distribution. Okay. Next thing to go along with our shape, if a distribution was symmetrical, then the mean should pretty much match the median, okay? Now, nothing has to be exact. Everything just has to be close. So our mean is 15.825 right here, and our median is 15.9. Well, you know what? I think that's pretty darn close, so that works, okay? Okay, to go along with what justifies a normal distribution, let's talk about the empirical rule. So the empirical rule says that 68% of the data will fall between 1 standard deviation above and below the mean. 95% of the data will fall within 2 standard deviations of the mean, and then 99.7% of the data will fall within 3 standard deviations of the mean. So let's check that, okay? So our data has to follow the empirical rule. So 68% of the observations are the mean plus or minus 1 standard deviation. So in this case, we're going to do our mean plus or minus 1 times the standard deviation. And if you put that in the calculator, 15.825 minus 1 times the standard deviation, you get 14.608. And if you do 15.825 plus 1 times the standard deviation, you get 17.042. And I'll leave you to put that in the calculator. So 68% of data has to fall between those two numbers. Okay, let's check it. So I'm going to go to my data. So 14.608 would be around here, right? And 17.042 would be around here. So let's see, these are 6. So that's 18, 19, 20, 22, 23, 24. So that's 24 out of 36. 24 out of 36, you can throw that in the calculator, is 67%. So not bad, not bad. Okay, the rest of our empirical rule, 95% of the observations have to fall within 2 standard deviations. So again, we'll redo our calculation, but this time we'll do 2 times the standard deviation. We'll subtract it from the mean, and then we'll add it to the mean. And we should get a range of, let's see, 13.391 to 18.259. Okay, so 13.391 is right around here. 18.25 is right here. So that's basically everything except 2 pieces of data. And there are 36. So this would be 34 out of 36. Ooh, and that's 94%. That's very close as well. Yay. And then the last part of the empirical rule says 99.7% of the observations fall within 3 standard deviations of the mean. So we're going to take our mean again, we're going to subtract and add 3 times the standard deviation. And again, throw that in the calculator, make sure your numbers match mine. Okay, so our last bit of data has to fall, between 12.17 and 19.4. Well, 12.17 is out here and 19.4 is out there. So it's basically all the data. So obviously 36 over 36 is 100%. And you know what? That's pretty darn close because 99.7 is practically 100%. So I think my data follows the empirical rule pretty close. Okay, so that's 3 things, 3 out of the 6. Okay. All right, let's go along with this 3 standard deviations. Now, in a normal curve, remember, I'm going to draw a little normal curve. Remember, in our normal curve, we've got 1, 2, 3 standard deviations above and below the mean. So a majority, 99.7% of the data is within those 3 standard deviations. So let's check that low -3 standard deviation value and that positive 3 standard deviation value against the min and the max, because they, again, should be pretty close, okay? So the min should be approximately equal to the mean minus 3 standard deviations, and the max should be pretty much equal to the mean plus 3 standard deviations, okay? Well, the min and the max are up in my numerical summary here, and I've already done the mean minus 3 standard deviations. That's 12.174. That's pretty close, not too bad. The maximum is 18.4, and my mean plus 3 standard deviations is 19.476. Okay, that's kind of getting a little far away, but not too bad. I guess I won't put a check there because it's not as strong as the others, okay? But it's still not bad. Okay, the fifth way, again, trying to work with our 5-number summary here, is let's check the quartiles, okay? Quartile 1 and quartile 3 are associated with percentiles. So Q1 is the 25th percentile. So let's try to find the 25th percentile of this distribution by using what we know about normal curves. So the 25th percentile, right, should be down here. And if I use inverse norm, which hopefully you've watched the videos about how to use that, you put the area to the left, and that yields you a z-score. Okay, so that is the z-score for the 25th percentile in a normal distribution always. Okay, so we have to take the z-score and figure out what observation it matches. Okay, so I'm going to put into my z-score formula, x minus the mean over the standard deviation, and then solve for x. And I get 15.15. So let's see how close that is to my first quartile. Oh, no, it's not. Whoops, that is my first quartile. Sorry, I'm looking at my paper that my ink stuff. Looking at my paper, which I've already calculated. Sorry, guys. It's actually 15.01. Okay, but that is very close to my Q1. Okay, so that 15.15 is pretty darn close to my 15.01, which is the observation that sits at the 25th percentile. Okay, is everybody good? All right, let's do the same thing with the third quartile, which matches the 75th percentile. Okay, now if I draw the curve, my 75th percentile is on this side because 75% of the data is equal to or less than that observation. I don't need to go through inverse norm again because from my 50th percentile, which is my median, my 25th and my 27th are equidistant from the median because it is a symmetrical distribution. So I know that this z-score is just the positive 0.67 because they are a symmetrical distribution. So I'm going to put this into my z-score formula and get the associated x with that, which is 16.64. And let's see how close that is to my Q3. Pretty good, pretty good. Okay, so 16.6 is pretty close to the x value associated with my 75th percentile. So that one I'm checking off. So far, 4 out of my 5 justifications to prove a distribution is normal are very strong. This one's not that bad, but it's just not as strong as the others. Okay, the last way to determine if a distribution is normal is your normal probability plot, which I'm going to abbreviate as NPP. Okay, you will never have to create a normal probability plot. You will always be given it. But here's a normal probability plot. What it is, it's your x value. In this case, it's our cubic feet of our refrigerator space against your z-scores. Okay, so these are z-scores. What we want from a normal probability plot is a nice linear graph. Okay, this definitely looks linear. So the more linear the normal probability plot is, the more proof that the distribution is approximately normal. Okay, so I'm going to say my NPP is linear, and that is a good proof or characteristic that means my distribution is approximately normal. Okay, Just as a little side, we'll do a little side note. What if my normal probability plot went like that? Okay, so it started off pretty straight, but then it veered to the left. Well, that means my distribution is probably left skewed. Okay, this is a parenthesis. And what if my normal probability plot started off straight, but then it veered to the right? So I'm going to draw a straight line, and when your data veers to the right, that means my distribution is right skewed. So if I had a normal probability plot that had that curve in it, the distribution would not be symmetrical, therefore it probably is not approximately normal. If it's got a really heavy skew, it's definitely not approximately normal. Okay, so I have pretty good evidence here that my distribution is approximately normal. So I would say, yes, the distribution of usable capacity in cubic feet for my side-by-side refrigerators is close to normal because the shape is roughly symmetrical and unimodal, the mean and the median match, my data follows my empirical rule very closely, my quartiles match my 25th and 75th percentile, and my normal probability plot has a very strong linear trend to it, okay? And again, my max and min aren't bad. They are very close to the 3 standard deviations above and below the mean, and that's fine. But he's the weakest out of all of them. But 5 out of 6 is pretty strong. Now, you probably will not have to do all 6 of these for a single question. It all depends on what you get, okay? So if all they give you was, say, the graph and the normal probability plot, they didn't give you any of this stuff, all you could really say is the graph is roughly symmetrical and unimodal, and the normal probability plot is linear, so that's proof that my distribution is approximately normal, okay? If they gave you your numerical summary, you could match the mean and the median. You could check your quartiles against the 25th and the 75th percentiles. You could check your min and max against the 3 standard deviations above and below the mean. But that's it. Okay, you couldn't talk about shape or normal probability plot or the empirical rule. The only time you can do the empirical rule is when you actually have your data. Okay, and that really probably actually doesn't happen a lot. Okay, most of the time you're given graphs and a numerical summary. Okay, so that is how you will prove that a distribution is approximately normal. And again, you don't have to prove this a lot. 9 times out of 10, you will be told that a distribution is approximately normal, and you'll be given the mean and the standard deviation so that you can work with it using normal CDF and so forth. Okay, I hope this was helpful, and I will see you guys the next time. Bye-bye.